So my name is Max Webers. I'm the co-founder and CEO of Colipi. Colipi scales two distinctly different technologies, both in the realm of precision fermentation. One is the classic yeast-based liquid fermentation, and here, which is non-GMO. Here we transform organic side streams, maybe from the chemical, from the food, from any agriculture industry, any side stream that contains sugars, starch, fatty acids, and other carbon chains. It can be consumed by the yeast and transformed to vitamin-containing oils. The oils are chemically equivalent to palm oil, and this means we have triacylglyceride, which is the scientific word for oil, with the fatty acid chains and the carbon length of C16, C18, C18, and C18. Long story short, exactly like palm oil. But also soybean oil, cocoa butter, and shea butter have fairly similar chemical profiles. Now there's a very distinct second technology, and here we do have a patent on a gas fermentation bioreactor and process. Hence it's a hardware and process patent, and it was published in the first week of August and can now internationally be revised. And here we scale precision gas fermentation. We have so-called knallgas bacteria that turn carbon dioxide with the help of hydrogen, which serves as the energy source, and oxygen. So yes, it's an aerobic fermentation to biomass. This biomass will have in future, we're working on it, triacylglycerides, again, because we are an oil company, just like the yeast, but also other biomaterials and obviously proteins are thinkable. Here, we need to do genetic engineering because the wild type strain only produces biomass, but no specific biomaterials. And the CO2 will come from point sources. So if there will be a text written, no, we're not a direct air capture company. We are more a carbon capture and transformation, biotransformation or utilization company. Our CO2 comes from point sources such as bioethanol plants, biogas plants, cement production plants, steel plants, of course, any fossil combustion process. If there's an energy plant in India, for example, burning ignite coal to produce electricity, this off-gas contains CO2 that we could outstrip or maybe even directly consume and turn to value. That's from the technology side. And again, this gas fermentation, this will really distinguish us from all the other startups that have been mentioned in this LinkedIn post, which is yeast fermentation. Its technical readiness level is 6 to 8, I think, for us and for most others. And the market is very, very big, meaning the vegetable oil markets in total amounts to 220 million tons a year, all vegetable oils. Palm oil alone is between 70 and 80 million tons. The market is big enough for 5 to 10 to 15 to 20 yeast oil startups. But the real breakthrough will be the gas fermentation. This is our differentiator. And here our big role models are, for example, companies like LanzaTech, which started 17 years ago. But LanzaTech is using gas fermentation to produce ethanol, alcohol, not oil.
Understood. That makes sense. And that also clarifies the differentiation between the two technologies that you just mentioned. Is it okay if I ask a couple of more questions?
Please.
So who is your ideal customer, in a sense? Is it the companies who want carbon capture and transformation, or is it the people who are in need of palm oil?
It's both. So for the business model, on one side, everyone that is paying carbon credits because they have a heavily CO2 emitting industry, they have a higher interest, or many times are even by law obliged to capture or utilize carbon. So there's many options. They could maybe pump the CO2 into the soil for sequestration, or they can create ethanol with LanzaTech with it, or maybe oil with us. And this oil can, for example, be turned to plastics, and plastics safe. PVC's flooring effectively act as a carbon sink. So they would sequester. It's CO2 emitting companies or companies that are not forced by law to avoid CO2. For example, biogenic CO2 from biogas or from fermentation startups. Biogenic CO2 right now is not yet punished by governments, but here it can be a value add. For them, it's a loss of carbon. It's a side stream they don't valorize. And we will tell them, look, with a little bit of hydrogen / electricity, our process and your CO2, you can even monetize this side stream and, make more revenue. So also those companies that do not have a pain by law may benefit economically. So the triacylglycerides will go to the oils. The triacylglycerides will go to biofuel, and here more specifically to the sustainable aviation fuel market. It's a mandated market. Governments in Europe and US and around the world force industries to have a biofuel plant in the aviation fuel. And I know it's public knowledge from many researchers, there is purely not enough feedstock. There's not enough used cooking oil. There's not enough palm oil, which also cannot also not be used for this. There's not enough renewable oil to fill this, to comply the law. So everyone is dearly looking for new feedstock. Besides that, since it has palm oil qualities, of course, food industries and cosmetics industries have a pain. Somehow the end customer doesn't like you and me, or maybe they don't like palm oil anymore, so it needs to be replaced by X, Y, Z. But it's hard to replace because palm oil is very, very cheap and abundantly available. For the marketing, we can help there, just to get it off the ingredients list.
Understood. You mentioned food industry, and that was going to be my next question. So food industry is specific in the sense that you need food grade certifications. You have to go through regulatory affairs. Is that something that you guys are looking to go through in the near future, or the focus is on the first part that you elaborated on?
It's on the first part that we elaborated on. Food is then a far-fetched goal, and the pain for food industry is less prominent than for the fossil oil industry or the aviation industry, where the law forces them to have sustainable aviation fuel, for example. For the food industry, it's almost a nice to have. There's still enough people eating Ferrero and other chocolates having palm oil. So end customer, I think maybe only in Europe, some people in the US avoid palm oil, but around the world, everyone I know from Southeast Asia and from India, everyone is using palm oil on a daily basis on the box and fries. So it's not, okay, long story short, for two reasons. The motivation of the industry is not big enough, and getting the food grade certifications is a huge challenge. So it will be the second or maybe even the third step.
Understood. I mean, the reason I asked that question is that I have a couple of clients who asked me about precision fermentation, and they are from chocolate industry, and they are also trying to produce lipids and fats. And it is also related to sustainability, because the cocoa that they get, I mean, it's sourced from somewhere else, and it's not right now sustainable because of climate change, because of the labor laws, so and so. Though they want everything to be close to home and lab grown, and they are thinking of precision fermentation there. And that's how I somehow was able to connect that maybe, I mean, this is a solution, at least technically, if not in terms of motivation and other things. But nevertheless.
Yes, we are already in commercial research projects with one of the most renowned chocolate and brands in the world, which I cannot disclose. But here it's on the side stream upcycling. So many chocolate industries in the world, they have food grade side streams, but they cannot sell it anymore. Now they dump it, and we can upcycle it to cosmetics oils. And this is a value proposition that you also may forward to your clients. Instead of paying sometimes waste fees to carry away old chocolate or whatever we could test them for a small research project if it's feasible to upcycle it to antioxidative vitamin containing yeast oil and make a business case out of it. And on the long run, potentially even mimic cocoa butter equivalents. Now I have been bragging about palm oil all the time.
Yeah.
As initially said, shea butter, cocoa butter, soybean oil, and palm oil almost have the same fatty acid profile. And we already managed at Colipi to have solid fat yeast, again, not bacteria, yeast fat, and solid at room temperature. And this means it could, with a little bit of more research, substitute cocoa butter, which is also, in marketing perspective, sometimes negatively connotated. Now, I listened to you when you said coconut. This is challenging. Coconut, like palm kernel oil, is medium chain fatty acids, which is C10, C12, C8 maybe. No, it's C10, C12. And this is unnatural to microorganisms.
Yeah.
It's poisonous to microorganisms. If they would produce it, they would be inhibited to grow. And to my knowledge, without genetic engineering, this wouldn't be possible either with yeast or with bacteria. So the food industry would probably, either we are lucky and find a new strain, not us, but any university research team or there, and finds cells that produce C10 and C12, or the food industry needs to accept that genetic engineering is the only way to achieve this. So unfortunately, in the near term, we will not replace coconut oil and palm kernel oil.
Understood. Makes sense. And maybe, then you also have a business background and you are managing things from the business end also currently. So the question that I usually ask is that what kind of hurdles are you facing in terms of commercializing the tech that you have? Do you already have clients? Is it commercialized? What kind of hurdles?
There are so many hurdles, but the biggest one boils down to who is paying and investing in the capex because we need a lot of steel and concrete to build huge bioreactors, and bioreactors need to be huge because it's heavily balanced on economy of scale. If we produce in, say, 100 liters bioreactors, then the fat will be very, very expensive. So just to give you an idea, commercial plants range anything from 500 cubic meters to maybe 1,000 cubic meters on one side, meaning that we would have maybe 5 times 100 cubic meters or 10 times 100 cubic meters. This is capex of, rule of thumb, maybe $150 million.
Yeah. So there needs to be a buy-in from the management.
Exactly, and no venture capitalist is investing in it. And companies like maybe big chocolate companies, or they wait for, I don't know, wonders. Someone needs to pay it, and it's more likely that those big industrials have good relations with their banks, which can get loans and then a little bit finance it by cash and a little bit finance it by whatever tools. It's not the startups. We cannot build the production capacities. So hurdle number 1. Hurdle number 2 is the price challenge. If we have a bioeconomy based on sugar cane or on corn sugars, like in China, we have a lot of corn starch turned to sugars. Sugar itself is a costly raw material and contributing to up to 80% of our production cost at scale. Not the electricity, not the employees, but the sugar cost. So industrializing on industrial side streams has an economic and a sustainability perspective, but side streams are very complex. Maybe they have some seasonality in quality and availability. Just to give you an instance, apples don't only grow in summertime in Europe. In winter, we do not have apple side streams. And India has harvesting seasons too. So side streams are very limited. So at the end of the day, we may again fall back to using sugarcane sugar or sugar beet sugar or cornstarch sugar as feedstock. I'm talking too much. Yeast fermentation will very likely always be 2 to 3 times, produce oils that are 2 to 3 times more expensive than palm oil.
Yeah. I mean, the price point is one of the major challenges that you have to maybe match, and that requires maybe honing or refining of the technology or scaling it up at some point of the time. Because, I was talking to another CEO and he was from the sugar reduction technique industry for food and juices and all those kind of places. And he mentioned that large players, they don't want to affect the bottom line. If they already have a product out there, they don't want to disrupt it unless, there is a price point match or a benefit that an alternate technology can give. And that may be my indirect question in terms of what would be the hurdle. You already answered that. So that makes sense.
So the yeast technology has its limitations, which is the price. For our patented gas fermentation basing on knallgas bacteria, here we have good hopes and first measurements from the laboratory and performance indicators that we could reach prices of palm oil prices. This could be the breakthrough because they are very efficient in turning an almost free carbon source, which is CO2. CO2 is cheaper than sugar. And very energy efficient. Yes, they need hydrogen. Hydrogen is the cost driver, so we hope that in future electrolyzers and electrolyzer will be efficient and electricity is available. There we have the chance to really satisfy the industry in producing at biochemical prices.
So then I had another question. It seems like you have a valuable tech and you have patented that. If there is a scenario where you have funding or acceleration from large players, would you be open to sharing licensing your technology to them?
Absolutely. And maybe this will be even the core business, because our highest interest is to create a whole new value chain from carbon dioxide, from off gas to fast moving consumer good businesses and everyone that is needing oil. So it's really a new value chain which hasn't existed in the world yet. And we need a fast, rapid diffusion of the technology to the market, which is only feasible with licensing. And we do not have the money to scale it. Like we don't have the money for the capex. Companies have it. The world is 2 degrees, maybe even more warming, and we don't have 50 to 100 years to become another BASF or Dow chemical. So no, licensing is even core. Yes, we are open to it. We ask for it. Thank you. Vikas, have a nice weekend. Enjoy the time with your family. Goodbye. Thank you.
You too, Max. Thank you.